All right, so I think this is recording. Let's take a look at solving this equation. It's a rational equation. I see ratios. I see variables in the denominator, so I have to be concerned about division by zero. So we need to check our final answers and make sure they're not extraneous solutions. On the left-hand side, I have a term that's x, and I want to write that as x divided by 1. And then I have minus 2 over x minus 3. And here, I don't have x minus 3. I have the opposite of x minus 3, which is 3 minus x. So if I factor out a negative sign from each term, I'll have negative 3 plus x. And you can see what I'm going to do now. When I have a negative sign in a fraction, then I have a choice. You'll see that negative sign written in front of the fraction bar like this. Or you'll see that negative sign maybe pushed up to the numerator and it looks like this. Or maybe you'll see that negative sign pushed down to the denominator and it'll look like that. So if you don't like my A and B, think about it as just what's the opposite of 1/2? Well, negative 1/2. What is negative 1 divided by a positive 2? What is positive 1 divided by a negative 2? All of these three fractions represent the same real number. They're the same number, but there's different ways to write them. And sometimes students do get confused with where to place a negative sign within a fraction. All right, so I'm going to move that negative sign to the numerator, and I'm going to rewrite this addition as x minus 3. So now I can see the denominator I want to have is x minus 3, and I can see that this first term is missing, this denominator is missing a factor of x minus 3. So now I'm in business because all of these terms, I'm going to go ahead and distribute that negative sign through there now. All of these terms have the same denominator. So if we multiply both sides of this equation by that common denominator, for every term, these denominators cancel, and what we have left is just the operations in the numerator. But we do have to slow down for a second. In multiplying both sides of a variable, both sides of an equation by a variable, you introduce the possibility of extraneous solutions when you have a variable in the denominator here. And we have to make sure that we don't make the claim that 3 is in the solution set, because there's no way that could be true. 3 minus 3 would cause division by 0. All right, so let's solve this. X squared minus 3x minus 2, negative x plus 1. This is a quadratic equation. We want to get this in standard form and look at it and see if we can factor, and if we can't factor, use the quadratic formula. All right. So let's add x to each side. So I have x squared minus 2x, and let's subtract 1 from each side. So I have minus 3 is equal to 0, and because this leading coefficient is 1, it makes it easy to see that this factors to x minus 3 times x plus 1, and this gives us possible solutions of 3 and of negative 1. But remember, we said that x can't be 3, so we have to throw this solution out. You're going to lose the majority of the points, if not all of the points, by forgetting to check for extraneous solutions. That's huge to understand that you're supposed to do that. And like I say, it is a common trick in algebra to, if you have x minus 2 to recognize that that's the opposite of 2 minus x, that if you change the order of subtraction, then you need to put a negative sign out in front. So hey, I hope that helps, and I will talk to you later. Bye.